Hello and welcome back to Sri Tech Education YouTube video channel. In today's lecture, we are going to study some multiple choice questions based on two-threaded gearing, which are important for the preparation of GATE exam, RTO exam, various MPSC and UPSC exams. So let us start. First question: two intersecting and coplanar shafts connected by gearing arrangement is known as. If suppose two gears are connected, then coplanar, intersecting and coplanar shafts are used. In that case, options are spur gear, helical gear, spiral gear and bevel gear. So the correct option is bevel gear as shown in this diagram. These two shafts are coplanar and intersecting. So D option will be correct. Second, if peripheral velocity of the gear is more than 15 meter per second, the gearing is known as. We have studied in previous lecture that if suppose the gear velocity is less than 3 meter per second, this type of gear is termed as low velocity gear. If velocity is between 3 to 15 meter per second, these are termed as medium velocity gears. If velocity is more than 15 meter per second, then these are called as high speed gears. So correct option for this will be high speed or high velocity gears. To study my previous lectures, video lectures, click on the suggestion box. There you will find the link for that videos, or go to description box. There will be link for that videos. Next, in an imaginary circle which by pure rolling action gives the same motion as the actual gear is known as. So this is the definition of pitch circle. An imaginary circle which by pure rolling action gives the same motion as that of actual gear is a pitch circle. This is the definition of pitch circle. In my previous video lecture of two-threaded gearing, we have studied this nomenclature, all the definitions in this nomenclature of two-threaded gearing. To study that, click on the suggestion link and find the video. Next, size of the gear is generally specified by, it is pitch circle diameter. Whatever definition we have seen previously is a pitch circle, and the diameter of that pitch circle is called as a pitch circle diameter. That is the basic size of the gear by which that gear is specified, pitch circle diameter. Next, according to law of gearing, minimum clearance should be 0.15 mm. Second, gear should be cut with a cutter having same module. Next, common normal at the point of contact between the pair of teeth must always pass through the pitch point or all of above. So the law of gearing is the C statement, that is a common normal at the point of contact between a pair of teeth must always pass through pitch point. In that diagram also you can observe that common normal Mn and the tangent, the common normal Mn has passed through the pitch point. So this is the law of gearing. So C option is correct for this fifth question. Next, the teeth which generally satisfy the law of gearing is two types of profile we have seen: involute tooth profile and cycloidal tooth profile. In that involute teeth and cycloidal teeth, now which teeth is generally satisfy this law of gearing? So this is cycloidal and this is the involute gear tooth profile. So both type of teeth profiles are satisfying this law of gearing. That's why we are using both of these type of gears. Next, if for power transmission a gear train consisting of 6 gears are used, then the motion of driver and follower will be in the A option same direction, B opposite direction, C both A and B, and D none of these. So if suppose 6 gears are used, consider that these are the 6 gears. First, suppose it is rotated clockwise, then what will be last or driven, that is last driven gear or last follower gear direction is asked. So imagine that first gear is rotating clockwise, second will be anti-clockwise, third will be again clockwise, fourth will be in anti-clockwise, fifth will be again clockwise, and sixth will be again anti-clockwise, that is opposite of the first. Therefore option will be opposite direction. So last follower will rotate, sixth gear will rotate in opposite direction of the first. If suppose even number of gears we are using, then this option will be remaining same. That means if suppose instead of 6 we are using 8 gears, 10 gears, 12 gears, 4 gears, 6 gears, then the direction of rotation of driver and driven will be in opposite direction always. And if suppose you are using odd number of gear, that is means 7, 9, 11, in that case the direction of rotation will be remaining same. That we will observe in next question. So eighth question is, if for power transmission a gear train consisting of 12 gears are used, then the motion of driver and follower will be. So as previously in seventh question we have seen that if suppose even number of gears are there, just like 12 or 6, the driver and follower direction will be in opposite direction. Next, if for power transmission a gear train consisting of 11 gears is used, then the motion of a driver and follower will be in the same direction, opposite direction, both or none of above. So if suppose odd number we are using, then the direction will be in same direction that we have observed previously. If even number of gears are there, then there will be direction of rotation will be opposite of driver and follower. If odd number of gears are there, then direction of rotation of driver and follower will be in the same direction. Remember this. Next, radial distance of a tooth from the pitch circle to the bottom of the teeth is known as. So in the gear terminology we have seen that the radial distance from the pitch circle to the bottom of the teeth is known as a dedendum. So correct option will be P option, dedendum. Next, radial distance of tooth from pitch circle to the top of the tooth is known as. So from pitch circle to top of the teeth is known as addendum. So correct option will be C, addendum. In a gears, the module is. So in this gear terminology, we have seen definition of module also. So what is module? Correct option for this module, we know that module is equal to ratio of d by t. That means it is the ratio of a pitch circle diameter to the pitch circle diameter to the number of teeth. So A option is length of the pitch circle diameter per tooth, number of teeth per unit length on pitch circle diameter, distance measured along pitch circle from a point on one tooth to the corresponding point on the adjacent tooth, none of above. So correct option will be A, that is d by t, that means length of pitch circle diameter to the tooth. Next, module is expressed in, just now we have seen m is equal to d by t, that means d is the pitch circle diameter in mm and t is the number of teeth. Therefore correct option will be C, mm per number of teeth. Next question, the ratio of number of teeth to the pitch circle diameter in mm is known as. Ratio of number of teeth to the pitch circle diameter. So previously module is equal to, we have seen d by t. Now here they have asked it is t by d. T by d is the diametral pitch. PD is equal to T by D, that we have studied. So correct option will be diametral pitch. It is the ratio of number of teeth to the pitch circle diameter in mm. Next question, two meshing gears must have same. So if suppose two gears are meshed, then the two gears must have same circular pitch, that is PC, that we have studied in previous lecture. If two gears are meshed, it should have same circular pitch. That means PC is equal to pi d1 by t1, that is the ratio of a formula for circular pitch. It is equal to pi d2 by t2 for second gear. If pi will get cancelled, then d1 by t1 is equal to d2 by t2. That means T by T ratio we have seen for what? It is for module. Therefore here M1 is equal to M2. That means if suppose circular pitch or module both are same, then two gears are meshing correctly. That means if two gears are meshing, they must have same module or circular pitch. If in option circular pitch is there, that will be also correct. If here is module is there, then also it will be correct. So module for this question, it is the correct answer. Next, module is reciprocal of module M is equal to D by T, and pitch diametral pitch PD is equal to T by D. Therefore module is reciprocal of diametral pitch. B will be the correct option. Next, radial distance from addendum circle to clearance circle is known as. So in this gear terminology diagram, observe that distance from addendum circle to clearance circle is known as a working depth. So correct option here will be C, working depth. Next, surface of the tooth below the pitch surface is known as a flank. So observe that pitch surface, it is along the pitch circle, and below that pitch surface, whatever surface of the gear tooth is there, that is called as a flank. So correct option here is a flank of the tooth. Next, the angle between the line of action and common tangent to the pitch surface is in the plane of rotation, it is known as. So common angle, see here Mn is a common tangent, which is tangent to the base circle and passing through the pitch point, and Mn is a common normal passing through pitch point, and a common tangent at point P, and the angle between that two things, that is common normal and common tangent, is known as a pressure angle. So correct option for this is A, pressure angle. Remember this. Next, pressure angle varies from, so generally pressure angle is varying from 14 degree to 20 degree. Remember this also, for pressure angle it varies from 14 degree to 20 degree. High pressure angle causes, if suppose this pressure angle increases, the wider base and stronger teeth will be formed. Their base will be wider and stronger teeth will be there for a high pressure angle. Next, in involute gears, first option is interference is inherently absent. For involute gear they are asking interference is inherently absent, pressure angle is constant throughout, convex flank is always in contact with the concave flank, none of above. So in involute gear tooth profiles, two types of profiles are there, involute and cycloidal. In that we have seen for involute gears, pressure angle is always remaining constant throughout. But in case of cycloidal gear tooth profile, pressure angle is varying from start of engagement to the end of engagement. But in case of involute gear tooth profile, this pressure angle is remaining constant throughout. This is the only difference between involute and cycloidal gear tooth profile regarding this pressure angle. Next, gears having minimum axial thrust is, so first spur, bevel, helical and double helical gears. So you can observe all diagrams for spur gear, for bevel gear, for helical gear and double helical gear. In case of double helical gear, there is a minimum axial thrust. Because of this less axial thrust, double helical gears are formed to generate less axial thrust. So correct option will be D, double helical gear. Next, the minimum number of teeth on the pinion of gear is calculated with consideration to minimize clearance, to avoid interference, to minimize diameter of the pinion, all of above. So in tooth gearing we have studied to calculate the minimum number of teeth on pinion as well as gear by considering to just avoid interference. At the time of avoiding interference, what should be minimum number of teeth on pinion and wheel? That we have calculated. Therefore, here correct option will be to avoid the interference. We have found the minimum number of teeth. Next, ratio of length of arc of contact to the circular pitch is known as length of arc of contact to the circular pitch. This ratio is called as a contact ratio. We know this formula of contact ratio, that is number of pair of teeth in contact. Significance of contact ratio is nothing but a number of pair of teeth in contact. So this is equal to length of arc of contact divided by circular pitch PC, and circular pitch PC can be given as a pi into m or pi d by t, that we have seen previously also. So correct option for this 25th question is contact ratio. Next, contact ratio of a gear should be, it should be always more than 1, or it is generally more than 1. Contact ratio is more than 1. Next, when tip of tooth undercut the root on its mating gear, it is known as, when tip of tooth undercuts its root of its mating gear, it is known as interference. So this should be avoided. Next, in cycloidal gear, so options are there: interference is inherently absent, pressure angle is constant throughout the teeth engagement. We have seen this for involute, that means it is wrong, option B. Next, center line distance varies within the limit, does not affect velocity ratio, or all of above. So correct option for this cycloidal gear is interference is inherently absent. In involute gear there may be chances of having interference. For avoiding that interference, we are using minimum number of teeth on pinion and wheel. But in case of cycloidal gear tooth profile, interference is inherently absent. It is generally not present for the cycloidal gear. Remember this. Next, locus of point on the circumference of circle which roll without slipping on a fixed straight line is known as. So two types of profiles are there. From that, this is the definition of cycloidal gear tooth profile or cycloidal profile. Locus of a point on a circumference of a circle. So here we have considered, in this diagram you can observe that we have considered one circle and it has been rolled on a straight line so that one curve is formed, and that curve is called as cycloid. So B option will be correct. Next, locus of point on the circumference of circle which rolls without slipping on the outside of another circle is known as outside. That means if suppose that circle has rolled outside a circle, previously we have rolled it over a straight path, here we have rolled on a circular surface, and that outside surface, if we roll the circle, then one profile is generated, and that is called as a epicycloid. And if suppose, next question is related to same thing, that is locus of point on the circumference of circle which rolls without slipping on the inside of another circle is known as inside. That means that D circle has rolled inside a pitch circle, that means another circle, then one curve PB is generated, that is called as a hypocycloid. If suppose it is outside, the curve is generated AP, and that AP curve is called as a epicycloid, whereas PB curve here is called as a hypocycloid. So by combining that AP and PB, one total curve has formed, and that is called as a cycloidal curve. But AP is called as a epicycloid and PB is called as a hypocycloid. Remember this. Next, a curve traced by the end of thread as it is upward from the stationary cylinder is known as curve traced by the end of thread as it is unwound from the stationary cylinder is known as. If suppose there is a curve traced by unwounding or unwrapping the thread end point from a stationary cylinder, just like in this diagram, if suppose one thread is wounded on this cylinder or base circle and is unwound at point A, A1, A2, A3, which are always tangent at P, P1, P2, P3. Then this, by joining A, A1, A2, A3 points, we have got one curve, and that curve is called as a involute curve. Remember, this curve is called as involute curve, and by joining this curve we have formed involute tooth profile. Next, the advantage of involute teeth over a cycloidal teeth is there are many advantages and disadvantages of both, but in this we'll see the option. The profile for the flank and face is a single curve. Yes, in case of involute we are having only one profile, that is involute tooth profile, but in case of cycloidal we have seen two types of profile we required, epicycloid and hypocycloid, which combined will form a cycloidal curve. So this is correct. Second, the pressure angle is constant from commencement to the end of engagement. Yes, we have seen this also. For involute gear tooth profile, the pressure angle is constant from start of engagement to end of engagement, but in case of cycloidal it varies. Next, straight teeth of a basic rack admits of a simple tool. Yes, straight teeth of a basic rack admits of a simple tools. By simple tools also we can form this. Next, D, variation in a center distance within limit does not affect the two mating gears. Yes, in case of involute gear tooth profile we can vary the center distance little bit, but in case of cycloidal we cannot vary that. So in case for involute, for this question number 33, all options are looking correct, but now here the option I think it is wrongly said as B, because all of options are looking correct, so correct it. For 33, E option will be correct. Comment in the comment box if there is some error in this 33rd question, 33rd question. Next, 34, path of contact in involute gear is a path of contact in involute gear is a straight line. Always remember, for involute or cycloidal, the path of start of engagement to end of engagement, that means path of contact is always a straight line. You can observe in this diagram that line is starting, that arrow is starting and ending, shown by a blue color. It is a straight path, therefore path of contact for involute gear is a straight path. Here also in this diagram you can observe from point K to L is path of contact, that means KPL is total path of contact, so shown by this arrow. So this is a straight path or straight line. Next, so this is for today's lecture. Thanks for watching my video. Subscribe and like the video, subscribe the channel if you are not subscribed. Thanks for watching.